So the topic of this video is vertical angles. And so up here I have the definition of vertical angles. Vertical angles are a pair of non-adjacent angles formed by intersecting lines. So let's kind of apply that definition to the picture below. Okay, so we have two intersecting lines, and we have a pair of non-adjacent angles. Adjacent will be a very good geometric word this year, especially in trigonometry later. Adjacent means next to, so a pair of angles that aren't next to each other. So for instance, 2 and 3, those are next to each other. But 1 and 3, those are not next to each other. So angle 1 and angle 3, that would fit this definition. Those are two angles formed by intersecting lines that are not next to each other. Similarly, angle 2 and angle 4 are also vertical angles. They are non-adjacent, they are not next to each other angles that are formed by a pair of intersecting lines. Okay, so even if you just looked at this, since these lines, we can assume that lines are straight, this is kind of drawn to scale. You might be thinking that angle 1 and angle 3 are equal to each other, or you might be thinking that the measure of angle 1 is equal to the measure of angle 3, and the measure of angle 2 is equal to the measure of angle 4. From looking at that, that might be something that you think. We may have talked about this in class. We'll even prove that that is in fact true in this class, maybe today or tomorrow. But if you look on the next slide, you can see where we kind of enforce that concept to show that all vertical angles are congruent. Okay, thanks. So here in this situation, we can start out with 28 degrees, and we know that we have a straight angle or a straight line, and we know the measure of a straight angle is 180 degrees. So we could do a little scratch work here and say something like, well, if we had a straight angle and we used up 28 of the degrees, how many are left over? Well, that's 152, okay? So to make this straight line right here, 152 plus 28 makes exactly 180. Make sure you do your math right with the tens there. Okay, so now we also have a straight angle or a straight line right here. If we have 152 degrees right here, the leftover would be 28 degrees. Okay, similarly, we have another straight angle here. We've used up 28 degrees right here, so this must be, well, I know 28 plus 152 makes 180, so that has to work perfectly. Okay, and then so what do we notice here? We notice, in fact, that these two angles are known as vertical angles, and they are congruent. Similarly, the 28 degree angles, they are both congruent as well, and they are vertical angles. So what is this quick demo really trying to show you? That all vertical angles, a little shorthand there for angles, are congruent. That symbol means congruent. Okay, it's you have the squiggly above the equal sign. So that's going to be a very, very important idea. And don't say, oh, these two angles, because they're vertical angles. You need to say these two angles are congruent because all vertical angles are congruent. So that's a very, very important theorem that we're going to use constantly in proofs. And this example was used to illustrate that. Okay, so since we just learned that all vertical angles are congruent, we have a situation here where we have two lines intersecting, so vertical angles are formed. So I know, and always mark up your diagram just as I am, I know that this angle on the left is congruent to this angle on the right because they are vertical angles and all vertical angles are congruent. Similarly, I know that this 60 degree angle down here is going to be congruent to this angle up here. Okay, so since we know that things are congruent, or their measures are equal, we can say, well, x minus 9, that's equal to 120 degrees because vertical angles are congruent. And we can also say that 3y plus 18, that is equal to 60 degrees. If we do a little algebra here, add 9 to both sides. Okay, so x is 129 degrees. And y, if we subtract 18 first, kind of isolate the variable y, we've got 42 here, divide by 3, divide by 3. And so y is 14. So we can solve for x or solve for y using this idea that vertical angles are congruent. And remember, vertical angles were formed because we had these two lines intersecting. So now here's like a famous sort of example, and I wanted to show you this in this video so that you can have this knowledge going forward. You've got to be very, very careful, because see how we have 5 angles here, and I'm trying to see where vertical angles are. And so if you notice, like, this line, this ray, it isn't actually forming a line. So we can't really use vertical angles on that. Some kids will say, like, oh, 2 and 5 go together because of vertical angles. That's not correct. We need 2 straight lines intersecting. So this line, maybe I'll call it line M, and this line, line N, they are intersecting and forming vertical angles. So again, kind of trace those out again. So what I know, if I'm looking at these 2 lines intersecting, I know that since all vertical angles are congruent, I know angle 5 is congruent to angle 3. So you could say something special like the measure of angle 5 equals the measure of angle 3. Why? Because all vertical angles are congruent. Now, the thing that's interesting, and kids tend to struggle with, is we're still talking about these 2 straight lines intersecting. I know that this bottom angle, the measure of angle 4, is the same as the measure of this entire thing up here. So that's very, very important, that since we have 2 lines intersecting here, and one, it's forming 2 congruent angles because all vertical angles are congruent. One of those angles is split by a ray, so the 2 components of that angle, the measure of angle 1 and the measure of angle 2, make up the measure of angle 4. So it's okay to have situations like this. And again, so the reason why this works is because we have 2 lines, 2 straight lines intersecting, and we know that when 2 straight lines intersect, vertical angles are congruent. So it's perfectly acceptable to say something like, well, this angle is comprised of 2 angles, and this angle is formed by 1 angle. We know that the measure of angle 4 equals the measure of angle 1 plus the measure of angle 2. And the big idea, and you really should write this down as you're making statements like this, you really should say something like, since all vertical angles are congruent. You should always be writing and justifying and knowing what you're doing is correct and true and factual. So be very, very careful. And just to reiterate one more time, the reason why the measure of angle 5 is not equal to the measure of angle 2 is because if you kind of dissected that, I'm just doing a little sketch here. Here's angle 5, here's angle 2. You do not have 2 straight lines intersecting. You have 1 line and then you have a couple of rays, and that's why vertical angles does not apply to that situation. So be very, very careful and mindful and look towards this in problems in your future. So now we have an example for you. What you'll need to do is you'll need to copy this down at the end of your notes, and you're going to need to try this and apply the ideas of this video. And one thing I haven't actually been writing down, but I really want you guys to do, you really should say, if you're going to do a problem like this, you should start to set yourself up and say, since vertical angles are congruent, and then I'll leave you at that. You can start to mark up your diagram, come up with true equations, and what you'll have to do is you have to solve this system using substitution or elimination. If you don't remember that, Google it or check it out on our website. And so you aren't done until you've actually solved for x and y in this problem. Good luck.